general format of your characteristic equation is what? Determinant of A minus lambda I equal to 0. Okay, this is your general format. Your general format, your A is your given matrix, lambda is your scalar, and I is your identity matrix. But when you use it in your formula for a 2 cross 2 matrix, since it is 2 cross 2 matrix, you will start it with lambda square minus S1 lambda plus S2 equal to 0. You know what is your S1? Your S1 is your sum of the main diagonal elements. S2 is your determinant of it. Okay, this is the 2 cross 2 matrix. For 3 cross 3 matrix, it will be lambda cube. It is 3 cross 3. So you'll start it with lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. This is for a 3 cross 3 matrix. And here your S1 will be the sum of the main diagonal. S2 will be the sum of the minus of the main diagonals. And S3 will be your determinant of it. Okay, so your characteristic equation you know to find out. From this characteristic equation, if they're asking you to verify whether it is satisfying your Cayley-Hamilton theorem, you know what you have to do. Your Cayley-Hamilton theorem statement you'll have to know every square matrix satisfies its own characteristic equation. So whatever your characteristic equation you have found out, instead of lambda, you will substitute your given matrix. Okay, and after substituting that given matrix, you will make it equal to 0 if it is a square matrix. After that, they can ask you in the question, find out your inverse, find out your a power 4, a power 6, a higher powers of your a. Okay, so with that given, whatever you verified, that equation you will multiply your a inverse to find out your a inverse. Okay, and similarly, if it is higher powers of a, you will multiply that given equation into that whatever power. Okay, so accordingly, you will multiply. That is your Cayley-Hamilton theorem. Then we went into your eigenvalues and eigenvectors. In your eigenvalues and eigenvectors also, you have to find out this characteristic equation, and then you'll have to solve this equation. If you solve this equation, if it is lambda cube, you will have 3 roots. If it is lambda square, you will have 2 roots. Okay, so that roots is nothing but is your eigenvalues. After finding out your eigenvalues, you have to find out your eigenvectors. Okay, so we will continue with that problem which we had done yesterday. Put today's date, start writing. So yesterday's that problem was you need to find out your eigenvalue and eigenvector for the 1, 0, minus 1 and 1, 2, 1, 2, 2 and okay. So this was your given matrix and your S1 was 6. So I will write directly your characteristic equation which you found out. The characteristic equation was lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. Okay, and you solve this using your synthetic division and got your eigenvalues to be your eigenvalues where lambda is equal to 1, 2 and 3. So you found out your eigenvalues to be 1, 2, 3. Now we have to find out your eigenvector. Okay, now your eigenvector, you have already known that your eigenvector, what was the formula I've given you know? It is A minus lambda I into your x equal to 0. Okay, for your eigenvector, this is your format. So A is your given matrix and x is this. Now listen, then you can write it. Okay, so for finding out your eigenvector, this is your general format. A will be the given matrix, lambda will be the eigenvalues which we are got. Okay, for each term, you will find out the eigenvector separately. So first we will start it with x. First, lambda is equal to 1. When lambda is equal to 1, yeah, when lambda is equal to 1, what would be the eigenvector? Okay, so your given matrix is A minus lambda I. and your x will be here. Since we are considering three roots, your x will be your x1, x2, and your okay. Since we are taking it for the first eigenvector, I have denoted as capital X. Okay. So when lambda is equal to 1, your given matrix A, I will write 1, 0, minus 1, 2, 2, 3. Okay, this is your given matrix. Minus lambda is nothing but you've got 1. Okay, that is your 1 and your identity matrix. So it will be minus, when it is identity matrix for a 3 cross 3 matrix, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Since your lambda here, you have taken it as 1, you've got the same value. Into your x is nothing but the whole term into your x1, x2, x3. Okay, into x1, x2, x3, which is equal to 0, 0, 0. Which is equal to 0, 0. So this is how you're going to find out your eigenvector. Now what you have to do, you have to minus it. So what you will get? 1 minus 1 will become 0. 0 minus 0, it is 0. Minus 1 minus 0 will be minus 1. Then 1 minus 0, 1. 2 minus 1, which is 1. 1 minus 0 is 1. 2 minus 0 is 2. 2 minus 0 is 2. 3 minus 1 is 2. Okay. So I've just subtracted it and then we will multiply it with your x1, x2, x3 is equal to your 0. 0. Okay. Now I will write it in the equation format. So this will be row into column. So it will be when 0 in anything with this 0. So you have minus x3 equal to 0. That will be the first equation. From your second row, which will be x1 plus x2 plus x3 equal to 0. Okay, from the second equation. From the third equation, it is 2x1 plus 2x2 plus 2x3 equal to 0. Did you understand how we are writing the equation? So how to find out the eigenvector? Whatever lambda values you have got, you have to start with the first one. Okay. So I have taken lambda is equal to 1. I have substituted lambda is equal to 1 in this given equation value. Okay, the scalar value. So 1 I have substituted into your identity matrix. So the given matrix into the minus your identity matrix, the whole term into your x. Okay, your x we take it as x1, x2, and x3. Okay, since we have taken this lambda is equal to 1 as the first one, so we represent it as x1. Okay, so we have got it and we have minused it and then we have multiplied it with your x1, x2, x3 and equated to 0. Now you have to find out the values of x1, x2 and x3. Will you write it down? You're finished, tell me. So here we will take this as first equation, second equation and third equation. If you've got any doubts, please ask me, because this will be the follow for all the problems. Do the same thing in all. Okay. So after finding out this first equation, all these equation, you have to see whether it is all different equation. Here, if you see your first equation is unique. Okay. So x3 is equal to 0 from that first equation itself. From your second and third, if you see, your second and third is different or same. See your second equation and your third equation. Is it same or different? Who and all are telling it is same?
Ma'am, in third equation, if we take 2 as common, it is same.
Very good. So your second equation and your third equation are the same equation. If you divide throughout by 2 in your third equation, you will get the same thing as your second equation. So these two equations are the same equation. So with that, you can't find out anything. Okay. So what we will do with your first equation and your second equation, we will formulate and find out your x1, x2, and x3. Okay. So how do you do it? You will do it by rule of cross multiplication. Do you remember that rule of cross multiplication? How many of you remember? X1, x2, x3. I am taking the values of this first and second equation. Okay, only the first equation and the second equation. So here it will be 0x1 plus 0x2. Okay, so I'm taking only the first equation and the second equation. I'm going to do it with your rule of cross multiplication. So in your rule of cross multiplication, how do you do? You will start it from your coefficient variable of your x2 term. So here it will become, I'm taking it from the first equation, it is 0. The same thing from this will be 1, then minus 1, 1, okay, and then come this side, it becomes 0 and 1, and you will complete it from the value which you have taken it, okay. So this is your rule of cross multiplication. I think probably you remember how to find out your values of x1, x2, and x3. Okay, you will write it like that. Then what you'll have to do? Then what you have to do? You have to write it as x1 by 0 minus 1, 1, 1 is equal to your x2 by minus 1, 0, 1, 1 is equal to x3 is equal divided by determinant 0, 0, 1, 1. So remember? Then you will find out your determinant. So x1 by 0 plus 1, x2 by minus 1, and x3 by 0. Okay. So from here, you can write your x1's value. What is your values? 1, minus 1, and 0. Do you remember your rule of cross multiplication, how to find out your x1, x2, x3? So how I will repeat it again for you. I've taken the first two equations since the same equation is your 2 and 3. Okay, if you do it with your 2 and 3, you will get 0. So you must not do the same equation. The equations which are different, you can do it by your rule of cross multiplication. So with these two values, what your two equations, I've taken the values. So x1, x2, x3, you have to write it down. You have to start it with the coefficient of your x2 term. Okay, you will start it with your coefficient of your x2 term. The 0, 1, I've taken these two equations. Okay, 0, 1 that I've taken. Next is minus 1, 1. Then we will come here, it is 0 and 1. And then we will finish it with a term which we have started. Okay, which is your coefficient of your x2 term. Then what you'll have to do, you have to combine. This will be one coefficient of this x1. This is the coefficient of this x2. And this will be the coefficient of your x3. After that, you will find out the determinant. That determinant value will become your eigenvector. So the first eigenvector when lambda is equal to 1 is 1 minus 1, 0. If at all you are getting it as minus 1, 1, 0 also, it is okay. Okay, you can get that value also. Write it down. If you've got doubts, you ask. Same way, we will find out for lambda is equal to 2. Same way, find out for lambda is equal to 2. You finished writing, tell me. So we have found out your eigenvector x1 to be 1, minus 1, and 0. If you have got your x1 to be 1, minus 1, 0. Next, we will find out for lambda is equal to 2. Okay, so write case 2. For lambda is equal to 1, write it as case 1. Okay. This is lambda is equal to 2. So for lambda is equal to 2 means your value will be a minus 2 lambda 2I into your x2 is equal to 0. Okay. Here also x2 will be the value x1, x2, x3. But here alone the values will become 2. Okay. 2 into your identity matrix. Okay. It will become 2 into your identity matrix. So here it will change here. Again now minus it. So it will be 1 minus 2, which will be minus 1, 0, 0, minus 1, 0, 1 minus, so it will be 1, 2 minus 2, it will be 0, 1 minus 1, 2 minus 0, 2, 2 minus 0, 2, 3 minus 2, 1 into your x1, x2, x3. Find out the equation. So it will be minus x1 plus 0x2 minus x3 equal to 0. Okay, this is the fourth equation. And then x1 plus 0x2 plus x3 is equal to 0. And third one, 2x1 plus 2x2 plus x3 equal to 0. Okay, so here again we have got three equations. In this three equation, all the three equations are different. They're different or any equations are same? We've got three equations here. See, so all the three equations different or same? If it is same, don't take that equation for finding out your x1, x2, x3 because it will become 0. Okay. So what do you do is you have to see. So in your fourth equation and your fifth equation, if you see, in your fourth equation, if you multiply by minus sign, okay, if you multiply it by minus sign, it will become your fifth equation. Okay. So when you multiply it with your minus sign, it will become x1 plus 0x2 and plus x3 is equal to 0. Okay. So the same term of as like your fifth equation, it will become. So these two equations are same. So you should not take it. Okay. For finding out your root x1, x2 and x3. So we will be taking your fifth equation and your sixth equation. We will take your fifth equation and your sixth equation. Find out your x1, x2 and x3. So how do you find out your x1, x2, x3? Tell me the values. Tell me the values. What you will be writing below your
0,
x1?
2,
Very good. 0, 2,
1,
then
1,
1, 1,
1,
then
2,
1, 2.
0, 2.
Very good. Okay. So you'll write it down, then write the values here. So it will be 0, 1, 2, 1, 1, 1, 1, 2, 1, 0, 2. So see whether you're getting this value. We are getting minus 2, minus 1. Okay. If at all you are taking your fourth equation and your sixth equation, you can probably get it as 2, 1, minus 2 because there is a negative sign. Okay. If you are getting like that also, it is correct only. The same problem can be x2 is equal to 2, 1, minus 2. Okay. The same thing can be written like this also. If you're getting your eigenvector like this, it is also correct. But you can't get it like -2 plus 1 and -2. That is wrong. It has to be in the same order, but the sign can differ. Okay, here it is minus. For these two sets, it is minus. Here it has become plus. And here it is. When lambda is equal to 2, your eigenvector x2, if you see, you have got to be -2, -1, and 2. Okay, we have got it as -2, -1, and 2. Can also be this also. Similarly, for your x1 can be -1, 1, and 0 also. Next, we will find out for lambda is equal to 3, your case 3. Okay, in your case 3, you will find out for lambda is equal to 3. So that will be a minus 3i into your x3. So here it will become you'll find out for now case 3, which is lambda is equal to 3. Because your eigenvalues were 1, 2, 3. Now we have found out your eigenvector for x1, x2. Now we will find out for x3. So for your x3, we take your lambda to be 3. Since your eigenvalues is 3, we are taking lambda is equal to 3. Whatever eigenvalue you have got, you will write it down. Okay, 1 minus 3 minus 2, 0, minus 1. Then 1 minus, it will be 1. 2 minus 3 minus 1. 1 minus 2 minus 2 minus x1, x2, and x3 equal to 0, 0. Okay, so first write the equation. So it is minus 2x1 plus 0x2 minus x3 equal to 0. Would be your seventh equation. X1 minus x2 plus x3 equal to 0. 2x1 plus 2x2 plus 0x3 equal to 0. Here if you see, the different or same? You've got 3 equations now. The 7, 8, 9, if you see, all the 3 equations are different. So any equation you can take. Only if it is same, you must not take the same equation. You will get it equal to 0. Okay. So you can take any 2 equations. Which 2 equations you want to take? 7, 8 or 7, 9? Which equation you want to take? Whatever equation you want to take, you can take. Which equation you want to take? All are different. So all are different. You can take any equation. Which do you want to take? You will take 7, 8 or 8, 9. You can take. We'll take 7, 8 itself. So I will taking your 7, 8 equation itself. So in a 7, 8 equation, it is 0, minus 1, then minus 1, 1. Then you've got minus 2, 1, 0, minus 1. Okay. And then find out your values 0, minus 1, minus 1, minus 1, minus 2, 1, 1, minus 2, 0, 1, minus 1. Find out the value. That is minus 1, plus 1 plus 2, 1. Then so your value is minus 1, 1, and 2. You're getting this? So this is your x3. Your eigenvector x3 is minus 1, 1, and 2. Okay, the same value can be 1, minus 1, minus 2. Eigenvector. So So you're finding out your eigenvectors. So in the final, what you have to do is you have to write all the values together. So how you have to write is, have you finished this day? Write it quickly. So you will write your final answer. First you will write your characteristic equation, then your eigenvalues, then you will write it as eigenvector. Your eigenvalues are 1, 2 and 3. So expand for eigenvector 1 was 1 minus 1 0. For your x2, what was your x2? X2 it was minus 2, minus 1 and 2. And for x3 it was, you can take one, minus 1, 1 and 2. And what was your characteristic equation? That also you have to write. Okay. This will be your final tableau. Okay. Your eigenvalue was what you have to write, and then you have to write the corresponding eigenvector. Write your characteristic equation. What was your characteristic equation? Lambda cube minus, what was the characteristic? Minus 6 lambda square plus 11 lambda minus 6 equal to 0. Okay, finally you have to conclude it like that. You have to write your characteristic equation, your eigenvalues, your eigenvectors, your corresponding eigenvectors. Okay. You're finished. We will go on to the next problem. Have you all finished? Any doubts you've got? So, in a given problem, what is your first step? You have to see whether it is symmetric or non-symmetric. Okay? Symmetric means what? If your given matrix is equal to A transpose, it is a symmetric matrix. If it is not equal to your A transpose, it is a non-symmetric. After finding out whether it is a symmetric and non-symmetric matrix, you will find out your characteristic equation. After finding out your characteristic equation, you have to find out your values of your lambda. How do you find out? You will do it by a synthetic division if it is a 3 cross 3 matrix. Okay. If it is a 2 cross 2 matrix, you will solve it using your quadratic equation. Solve it, get your values of lambda. After finding out your values of lambda, find out your eigen. Okay. So write the question. Find the eigenvalues and eigenvectors of the matrix A is equal to 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. This is your given matrix. Find out. First see whether it is a symmetric matrix or a non-symmetric matrix. Is it a symmetric matrix or a non-symmetric? Symmetric matrix means what? Symmetric matrix means if your given matrix, if it is to your A transpose, it is a symmetric matrix. If it is not equal, it is not a symmetric. Okay, how do you see it? The values above and below your diagonal elements, if it is the same, that is, the order is the same, means it is a symmetric matrix. Okay, here if you see, it is minus 2, minus 2, minus 2. Otherwise, if you are getting that also to be confusing, find out your A transpose. Your A transpose, you will take your rows to be columns. So rows is 7 minus 2, 0. So 7 minus 2, 0. Minus 2, 6 minus 2, 0, minus 2, and 5. Okay. To see whether it is equal, both are equal. So since A is equal to A transpose, what does it imply? It is a symmetric matrix. It is a symmetric matrix. So that will be your first step. Okay, you will tell whether it is a symmetric matrix or a non-symmetric. So it is a symmetric matrix. After finding out that it is a symmetric matrix, find out your characteristic equation. This is a 3 cross 3 matrix. So find out your formula. Write down your formula. Write down your formula and find out your S1, S2, S3. So your characteristic equation will be lambda cube. Always write your formula. For formula, mark is there. Always you'll have to write your formula. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Tell me what is your S1, S2 and S3. You will tell me what is your S1, S2 and S3. Your S1, find out the total. Your S1. Put it in your calculator and tell me. It's just the sum of the main diagonal elements. So what is your sum of the main diagonal? 7 plus 6 plus 5. What do you get? Get up and work it out.
18.
You're getting very good. You're getting 18. Next, find out your sum of the main diagonal elements. Okay, sum of the minors of the main diagonal. 7, 6, and 5. Find out your minus. Find out the minus. Concentrate and do. So what do you get? Anyone get?
$26.
There? Very good. This is 0. And then here. 38.
Ma'am, it's 35 no, ma'am. Some Faiza.
Here. Very. I saw the 0. I just put. Then this one.
38.
Okay. So what is your S2? Add it. 89.
99.
Okay. So your S2 is 92. 99. Okay, so your S2 is 99. Similarly, find out your S3. Find out your determinant of A. Must not take so much of time. Do it really very fast, otherwise you won't have time. You have to do it very fast. Twenty 6 into 7. What are you getting? You getting 182?
Yes, ma'am.
Your S, so your S3 is 162. Okay. So we found out your S1, S2, and S3. So your equation will become lambda cube minus your S1 was 18 lambda square, and then plus 99 lambda minus 162 equal to 0. So this is the equation which we have got. Your characteristic equation is this one. Okay. Now using your synthetic division, you'll have to find out your value of lambda. You have to solve it. How do you solve it? For finding out the values, what you can actually do is you can directly substitute the values of lambda in this equation and you can find out. Okay, you can put it equal to 1. See whether it is equal to 0. If it is not equal to 0, don't find out for 1. If it is minus 1, is it equal to 0? Then don't use it. If it is not equal to 0, don't take it at value. If you put it as equal to 2, if it is equal to 0, start with 2. Okay. That is, you are able to understand now. If lambda is equal to 1, if I substitute it here, you'll have 1 minus 18 plus 99 minus 162. This is not equal to 0. Okay. Similarly, for lambda is equal to minus 1. Substitute it here and see minus 1 you'll have minus 18 minus 99 minus 162. So this is also not equal to 0. To find out the value for your synthetic division, we can try out like this. Similarly, for lambda is equal to 2, that equation, if you substitute, it will become 8 minus multiply and see whether it is equal to 0. If it is equal to 0, start it with 2. That is, you will take your value here 1 minus 18, 99 and minus 162. Your prime idea of this is to make this value here, or it has to come 162 and make this 0. Okay, so if you make it to be 0, what it has to satisfy? When you're substituting the values for your lambda, it has to satisfy. So if you put this 2, see whether it is becoming equal to 0 when you substitute it in that equation. If it is not equal to 0, then don't take that value, go on to minus 2. If you're substituting a minus 2, if it is equal to 0, substitute it here and get the value. If your minus 2 is also not getting equal to 0, go on to lambda is equal to 3. Okay, so you will try it and find out your eigenvalues, eigenvectors. Okay, tell me your attendance. 1.
Present, ma'am.